Well, folks, after many experiments, I think I have really solved the sound problem here, because it turns out that the audio jack to the Type-C connection in my laptop works. The audio jack itself is not working for whatever reason. And I bought a converter adapter to go from the audio jack to C, which was a cheap one, which was not working very well. I paid 900 rupees for the adapter, and this seems to work like a charm, except I have to remember the button that mutes the mic. Okay. Now that you know the unnecessary details, let's continue with the ocean CDR, or ocean CO2 removal, carbon dioxide removal. This is kind of an opinion article, not opinion, but a research report rather than a research article. An article on an alkaline solution. As alarm about climate change grows, scientists explore a strategy for drawing excess carbon dioxide into the ocean. So here is a picture of a pink alkaline slurry that was released into the Halifax harbor during an experiment in October. Whenever such open system experiments are done, you have to be careful, but ocean is safer in the sense that this small experiment will not spread to global ocean or even regional ocean necessarily. Things will dissipate away, as opposed to, let's say, spraying dust in the stratosphere, because depending on how much you put into the atmosphere, you can have unintended consequences. So it's one thing to do uncontrolled experiments, another to know how controlled they are and what the unintended consequences are. So we'll just read some text from this. It's a short article, but I make it even shorter because I'm always brief. So some words from here. Standing on the aft deck of a modified 13-meter fishing boat in Halifax Harbor, Daria Atamanchuk gazes at both cause of the climate crisis and, she hopes, part of the solution. Well, climate crisis is a word that I know I always complain about. On the nearby shore, 3 red and white striped smokestacks rise like enormous harbor poles, funneling carbon dioxide from a natural gas-fueled power plant into the pale morning sky. At the seawall in front of the plant, seawater used to cool its piping flows into the harbor. Normally, that water runs clear, but today the outflow roils in a pink froth like a cauldron of Pepto-Bismol, which is a drug used mostly in North America for, acidic. If you have acidity in your stomach, you tend to take a Pepto-Bismol on, over-the-top medicine that you can just buy without doctor's prescription. Ooh, that's very milky, says Atamanchuk, a chemical oceanographer at Dalhousie University. Halifax is a beautiful place, and Dalhousie is a very well-known university. The colorful eruption, part of an experiment led by the Halifax, Canada-based company Planetary Technologies, contains red rhodamine dye and a slurry of white magnesium hydroxide, the main ingredient in the drugstore antacid milk of magnesia. The alkaline mineral should in theory raise the pH in the surrounding seawater, triggering a chemical reaction that will absorb CO2 from the atmosphere and convert it to bicarbonate, and an ion that can float through the ocean undisturbed for millennia. Well, a lot of reactions there. Basically, H2O plus CO2 gives you H2CO3, which splits into HCO3 minus and plus H plus, and then becomes CO3 minus minus plus H plus, which is the reaction in the ocean that buffers the ocean against getting saturated as CO2 keeps dissolving into the water. So to enhance this reaction, pH has to be increased. So pH in the surrounding water is raised by this alkaline mineral. Remember, ocean maintains the pH at around 8.1, 8.2, has done it for many tens of millions of years, but increasing CO2 in the atmosphere dissolving into the ocean is lowering the pH. We call it acidification. In the past few years, this relatively simple reaction has attracted a swarm of philanthropists, government officials, and climate entrepreneurs growing alarm about the pace of climate warming and the prospect of a market for carbon removal credits that could reach $1 trillion by the middle of the next decade are driving much of the activity. Researchers like Atamanchuk, who once had little interest in tinkering with the climate, are joining the throng drawn by a flood of research money, of research money, not food of research money, and a desire to understand the promise and perils of pouring alkaline substances into the world's oceans in quantities that could rise to billions of tons. Are we really sure about unintended consequences here? Well, we have to wait and see, right? The ocean already contains roughly 40 trillion tons of carbon, an amount that dwarfs the roughly 1 trillion tons in the air and 3.5 trillion tons in the land ecosystems. Some comes from marine plants and animals whose dead bodies and feces sink to the ocean floor, but the vast majority, more than 90%, is in the form of two inorganic ions, carbonate and bicarbonate. The reactions depend on the presence of alkaline minerals found in the rocks such as limestone, which are dissolved by rainwater washed into the sea, the weathering that we talk about. So CO2 also dissolves into rainwater, causes weathering, which washes into the oceans. Once dissolved, these minerals release hydroxide ions that can join with CO2 to make bicarbonate. So ocean keeps moving between H2CO3, bicarbonate, carbonate to maintain its pH. The alkaline mineral brucite can raise the pH of ocean water and trigger carbon dioxide capturing reactions, because ocean wants to move things between H2CO3, CO3 minus, CO3 minus minus, and acidification is where CO3 minus minus is lost, which is bad news for calcifying organisms like corals and shell-forming animals and so on. Here is Daria Atamanchuk here, lowers a device that will measure pH and other aspects of ocean chemistry into Halifax Harbor. Matthew Dever, I don't know how these names are pronounced, an oceanographer with the instrument company RBR, prepares to deploy a remote-controlled underwater glider that will track changes in ocean chemistry. All good, well-intentioned people. Any missteps could derail plans, as the proponents of ocean alkalinity enhancement are keenly aware. Some point to the furor that erupted 11 years ago when a fishing boat floating near the Haida Gwaii archipelago off the west coast of Canada dumped 120 tons of iron sulfate and iron oxide into the water. The iron fertilized plankton growth, igniting a bloom visible from space was created. The iron fertilized plankton growth, igniting a bloom visible from space. Proponents said the approach would boost salmon runs and capture CO2. Basically, in the ocean, iron is deficient, then enough, even if other nutrients like nitrate are available, phytoplankton are not able to photosynthesize even when light is available, but adding iron boosts photosynthesis and then the food chain, which should increase salmon and capture CO2 by photosynthesis, but there are lots of details that we have discussed elsewhere. This is what is involved: ocean engineering in an effort to combat climate change. Scientists are exploring ways to coax the ocean to absorb more carbon dioxide from the atmosphere by altering its water chemistry, a strategy known as ocean alkalinity enhancement. Delivering alkalinity, a number of delivery methods are currently under consideration, some ship-based and other coming from the shore. The pink color is included for visualizing purposes. Dye is only used in some experiments to track the spread. So here is the alkaline material, here is the intake of the power plants, I guess, so or this is the experimental setup. So you are releasing this here and then you are recycling by taking in the waters. So you have to take ocean water, increase its pH and release it back, and I suspect. So you have also releasing going on here. So one Ship spreading, alkaline materials such as limestone or olivine could be ground up and dissolved in the water and then poured into the ocean from a ship, basically mimicking real processes that happen. Alkalinity factories, sewage treatment or power plants could inject alkaline solutions into pipes leading to the ocean. Electrochemical treatments could also raise pH of seawater. So they are taking water often to cool and to do other things for which water is needed, and then they release it back often with too high a temperature or too low a pH, let's say, and other pollutions. Beach erosion, ground up alkaline rocks could be spread on beaches where they would gradually wash into the ocean and dissolve. Even on land, enhanced weathering is proposed, where olivine, which weathers nicely, can be ground up and spread on land, and let's say farmland, to enhance weathering, produce carbon, increase soil carbon content, and so on. But read the details elsewhere. I will have other podcasts here as well. But obviously, you have to do a life cycle analysis, or how much power it will take to grind up these rocks and transport them and put them in the on the soil, and you have to monitor how soil gets affected and so on. So here is the Planetary Technologies plans to conduct more ocean alkalinity enhanced experiments in the Halifax Harbor. So they plan to do this. Enhancing carbon cycle, boosting the alkalinity of ocean water can accelerate a natural process shown below, in order that sucks airborne CO2 into the ocean and converts into bicarbonate. So CO2 dissolves into the ocean. Maintaining the equilibrium is required. CO2 is exchanged between the atmosphere and the surface waters. Over time, an equilibrium can be reached, but it can dissolve much more because ocean keeps moving carbonic acid into HCO3 minus and CO3 minus minus. So adding alkalinity with solid milk of magnesia here can increase pH, which forces the ocean water to move things around into bicarbonate, so dissolves more CO2. When scientists dissolve alkaline substances such as magnesium hydroxide in the ocean, hydroxide ions are produced. Carbon capture, hydroxide ions react with aqueous CO2, creating bicarbonate ions which can float in the ocean for millennia. Okay. Room for more. With fewer CO2 molecules in the water, some CO2 moves out of the atmosphere into the ocean to restore equilibrium. Basically, if you move H2CO3 into HCO3 minus, then more CO2 goes into the ocean, which is the buffering effect. Okay, what is the research? Research on alkalinity enhancement is in its infancy, but there are signs it will grow up fast. If you had predicted 3 years ago I would be almost exclusively focused on this now, I would have laughed. Fennell says, Katya Fennell, I suspect, from Dalhousie. The burst of scientific activity has been fueled by a growing stream of research dollars from companies, universities, philanthropists, and governments. The funding for Fennell and Adamanchuk's work is part of the $50 million investment from Carbon to Sea non-profit. Dalhousie recently unveiled a Canadian $400 million initiative to study the ocean's role in climate change, including a focus on carbon capture methods. In the United States, the National Oceanic and Atmospheric Administration in September announced $24 million in research grants for ocean carbon removal, with 65% of the money going to alkalinity-related work. So that's a major part of the ocean CDR. And in Europe, the German government recently committed 11.6 million euros to alkalinity research. So finally, many industry players are keen to scale up and get approval for large projects like these, but they are reluctant to get too far out in front. The Ocean Conservancy's Cooley says early movers will be the first to navigate untested regulatory waters, confront technical conundrums, and woo a public wary of schemes to rewire the planet to tackle climate change. Everybody is rushing to be second, she says. Nobody wants to be the first, because they just want whoever is first to break the path. So everybody is worried about unintended consequences and regulations and lawsuits and legal liabilities and so on. So they want to see if others succeed, and everybody will be jumping on the boat very fast. Again, the distance between my head and the top is too high for some aesthetic people, but the sound should be good now. Okay, so see you. I will add another schematic infographic to this from Ocean Solutions, another NGO. Okay, see you in a minute.